Here we have the 2.8 chapter notes. We're going to talk about similar figures and proportions and how that deals with the proportions. So I just wanted to say if two figures have the same shape but not the same size, they are said to be similar. And here we can see we have two similar figures. I've shown these on your paper here because I want to see what it means for something to be similar. Down here, this tells us that triangle ABC is similar to triangle DEF. Well, here we have triangle ABC is similar to triangle DEF. So that squiggly line there, that just means similar. Again, they have the same exact shape, but not necessarily the same size. Okay. So, again, we know this means similar. Similar. Alright, so if triangles are similar, then the ratio of the sides are what? So the ratio of this side is what in comparison to this side? Well, the ratio of the sides are equal. So now we get to name the three equivalent ratios. Well, A to B over DE, so we have the distance from A to B, and here's how we say the distance of the side. AB over and DE, because that's the corresponding side. DE. We show that with a little bar over those. So that ratio is equal to BC over EF. So we have BC, the corresponding sides. Our ratio of the corresponding sides are equal. So EF. And the third ratio here would be CA over FD. Now, can you write them in different order? Sure. CA is the same thing as the distance from A to C, so it doesn't necessarily matter the order of the numbers, or excuse me, order of the letters that correspond. It just matters that this is the side between C and A. So I could say A to C or C to A. That part's okay. So these are the three equivalent ratios. All right. So another thing about similar figures is that the corresponding angles are going to be equal. So that means that the angle for this triangle here, this angle for A, this angle measure, is the exact same as this angle measure. And the angle measure for B is the exact same as the angle measure for E. Notice how I made them different, because we don't know that the angle measure is the same, but when I say 1, that's the same as this 1. 2 is the same as this 2. Okay? Now, it says name the three corresponding angles. Okay? Well, I know that the measure of angle A equals the measure of angle D. Now there's a lot of symbols, and that's okay. This symbol here just means this angle. Whatever angle that corresponds to A, well, that's going to be this angle here, is equal to the angle corresponding with D. Is equal to this angle. And really, just looking at it, we could tell that's definitely true. So the other ones would be the measure of angle B is equal to the measure of angle E. And the measure of angle C is equal to the measure of angle F. Oh, that one was pretty bad. Let me write that a little bit neater. The measure of angle F. There we go. Oh, not too bad. Okay, so now we have to use this knowledge of ours to find the missing links of these triangles. So where are our missing links? We're missing a length here. We don't know the length of A to C, and we don't know the length of Z to Y. But I know that the measure, the ratio of x, the distance between x and z, so that side length compared with AC, that side length is equivalent to, well, here I already have these two already set up for me, so I have the measure of the distance between x, y, so excuse me, the side length of x y over the side length a b. So the ratio of this over this is equal to this over this length. So xz over AC is equal to xy over AB. In other words, the distance from here to here divided by the distance of here to here is the same as the distance from x to y over A to B. And what do I need? Well, I need A to C. So, I know the values for xz, xy, and AB. I don't know the value for A to C. So, making a plan on how to put this together, what I can do is I can say my measurements for all of these. So I have 18 over AC equals, well, xy is 11 and AB is 33. What do I know? What do I need? And here's my plan. So, again, let's just treat this like a variable. We're going to treat this like a variable. I'm going to multiply both sides by AC. Multiply both sides by AC. So now I have 18 equals, well, 11/33. I can reduce this, can't I? Isn't that just 1/3? This is just 1/3. So I have 1 times, excuse me, let's just cancel these out. This is 3, and this is just a 1. So 1 times AC is AC. And 3 times 1 is 3. Now I can multiply both sides by 3. And 18 times 3 is 46. No, it's not. No, it is not. What is it? 54. Excuse me. 54 is the length of AC. Let's see if you can find the missing side length for ZY on your own. And if you want to work ahead, I'm going to go ahead and put the homework assignment for 2.8. It's going to be a short one. We are only going to do problems 6 through 11 and 23. I want you to do all of these problems, and 6 through 11 all, and 23. And the page number, because I know you guys like those, the page number is 133. Whoop, 134. So, I'll look on page 134.